Welcome to video number 3 on circles. In the last video, we learned that the equation for the parent circle was x squared plus y squared equals r squared. Further, we learned that to be a circle, the coefficients in front of the x squared and the y squared term both must match and both must be positive. Now, this particular parent circle and all parent circles are centered at the origin 0, 0, and they have a radius of r. Now notice I could have written this equation a little differently. I could have said that technically x squared is really like x minus 0 squared, and y squared is really like y minus 0 squared. So you can see that the center point actually comes from the two values here, okay? Now, we're going to do something a little more general. We're going to learn about something called standard form. And standard form can get us any circle on the entire coordinate plane. So to be in standard form, we're going to do the following. It's going to be x minus h, the quantity squared. Okay, and h is going to stand for the horizontal shift, just like it does in all other functions we learned about, plus the quantity y minus k squared. K will stand for the vertical shift, just like it does in other functions we learned about, equals r squared. Okay? And in this case, the center of the circle is going to be generically located at the point hk. And the radius is going to be r, okay? So importantly, h represents the horizontal shift, k represents a vertical shift. So it's very similar to everything else that you've learned in math. So let's take some examples of how I operate with standard form. So example 1, and this is in your PowerPoint notes, but I'm just going to write it out for you. It's asking me, given the equation of a circle, identify the center and radius of each circle. So example 1 gives me the following equation. The quantity x minus 1 squared plus the quantity y plus 3 squared, and that's going to equal 4. Okay, so we have to play a little bit of a detective here and figure out what happened. So the center is going to be hk. Now let's think about that carefully. For this to appear like x minus 1, 1 had to go into this equation as a positive number, right? Think about x minus h, right? H itself had to be positive. For y plus 3, for this to appear as a positive 3, if we look at our original formula, k had to go into that formula as a negative, right? This really was y minus a minus 3, which got us to y plus 3. So I know that the k value is negative 3, and I know that the center of my circle is at 1, negative 3. Now the radius, okay, again, we have to be a little bit of a detective. The standard form, right, which this is in, is r squared. So the 4 is equal to r squared. So r itself, I need to take the square root of this number. The radius is 2. So I encourage you to pause this video and make an effort to graph this on Desmos and convince yourself, if you type this in correctly with the right parentheses, you will see the center is at 1, negative 3, and the radius is 2 units long. Okay, let's do another example, example number 2. So again, same problem, identify the center and the radius. So I have the quantity x plus 2 squared plus the quantity y minus 6 squared equals 17. Well, here the center, okay, the h value must be negative 2, right? That's how it goes into the formula to appear like x plus 2. It must have been x minus a minus 2 to get me here. So that's a negative 2. And the k value must have been a positive 6 to appear like y minus 6. So the center is at 2, 6. And the radius, okay, if r squared right, is equal to 17, then r is equal to the square root of 17. And we're going to leave all of our radii in simplest radical form. Okay, let's look at example number 3. And in example number 3, I think I tried to trick you a little bit. Okay, yes, I did. I said -9 equals -y squared minus x squared. And you might be saying, wait a minute, I've been paying attention in all of these videos. How is that a circle? Didn't you say that the coefficients in front of x and y have to be positive? How can you get away with telling me that that's a circle? Well, it is a circle if you understand that these are just coefficients. And if I divide every single term by -1, and I get 9 equals y squared plus x squared, and then you know me, I have to rewrite this. I don't like how that looks. X squared plus y squared equals 9. Now I'm convinced it's a circle. I know the center is going to be 0, 0, and I know the radius is going to be the square root of 9, which is just 3. So I encourage you, before we move on to the next video, to go on Desmos and graph these 3 equations and make sure that you understand the horizontal and the vertical movement when I take a circle and shift it away from the origin.